Welcome back to Mathematical Statistics. I'm Mark Ledbetter. This is Lecture 1, Video 2. We are approximating discrete distributions using the normal distribution. So last time we went over the continuity correction. We went over the binomial, how to approximate the binomial distribution using the normal distribution. And we're going to continue with some more examples in this video. All right, so now we said that last time that we need at least 10 in order to meet the criteria for the guidelines. So now we've increased, we have the same problem, but now we're increasing n to 20, okay? And we still have, and we're going to call this V, is the sum of these 20 trials that we're going to have, or 20 random variables. So n is 20. And P is still 0.25. We have that four-sided die that we're looking at. And we want to find the probability that V is 0, 4, and 10. All right, so now, first we need to look at the requirements. So mu is equal to NP is equal to 20 times 1/4, which is equal to 5. So we meet the requirement, but just barely. I mean, we're at the minimum there. And that's going to cause us a problem, okay? So n is really not all that big in this case. And then nq is going to be the remainder, but it would be 20 times 3/4, which is 15. So these two values need to add up to n, because they're either in one category or the other. And so this definitely meets our requirements, but you'll see that p is not close to 0.5, so these numbers are uneven, so we are really dealing with the 5 is the situation. So the 5 is just on the limit, and it's going to cause our errors to be larger than we'd like. Okay. Now, let's start with probability V equals 0. This is the probability that V is between negative 0.5 and positive 0.5. We're subtracting a half and adding a half to, this is K. And then we're going to do our transformation. And so we're going to take negative 0.5 minus the mean divided by the standard deviation. So here we've said that V is binomial 20 and 0.25. And mu we calculated as 5. Sigma squared is NPQ equals 20, 1/4, 3/4. And so we've got 3... Let's see, we're going to have 15/4, which is 3.75. That's our variance. So square root of 3.75, and then this becomes W, and then we have positive 0.5 minus, and I need to subtract 5 as the mean, divided by 3.75. Now, if we solve this, we get negative 2.84 and negative 2.32, and now comes our approximation. We're going to change W to Z, which is the standard normal, negative 2.84, Z, negative 2.32, and this is equal to phi of negative 2.32, we take the bigger number, minus phi of negative 2.84. Now we need to look those up in our normal table. So they're negative, so we'll go to the second table. And remember, this is just like looking up the phi of the negative. So we have a negative 2.32 is the bigger one. So 2.3, need to choose 2.3012, so 0.0102, and then I have negative 2.84, 2.8012340023. So we're going to go back, we're going to plug in those values, and this is going to be 0.0102 minus 0.0023, which is 0.0079. Now, okay. Now let's look at the probability that V is equal to 4. Oh, by the way, if you calculate this up, the actual is equal to 0.0032, And so we have 146.9% error. Ouch. Okay. And I won't go through the calculations. I did it last time. So it's the estimated minus the actual divided by the estimated. And in this case, we are larger than the actual. So we are positive. So we'd have a positive value here. But the error, remember, is always just an absolute value. Okay, the probability that V is 4, probability that V is between 3.5 and 4.5. That's our continuity correction. And this is equal to the probability that we take 3.5 minus the mean, which is 5, divided by the standard deviation, which is the square root of 3.75. And this is W now. And then we do the same thing with 4.5 and 3.75. We still have negative values on both sides. This is the probability that W is between negative 0.77 and negative 0.26. Now our approximation is we change to the standard normal, Z, negative 0.77, negative 0.26, which is equal to, phi of negative 0.26 minus phi of negative 0.77. We go to our table, and I'm going to clear real quick. And then we're wanting this negative table, table B, and we're looking up negative 0.26 and negative 0.77. Negative 256. Okay, so 3974. And then negative 0.77. 0, 1, 2, 3, 4, 5, 6, 7, 2206. Okay, so now we need to plug those in. So this is 0.3974 minus 0.2206, which gives us 0.1768. Now this turns out to be the actual is equal to, I don't have it down here, but this turns out to be an error of only 6.8%. Okay, so much better. And then we'll do the probability that V is equal to 10, and this is going to be the continuity correction, 9.5 to 10.5. We'll do the transformation next. So 9.5 minus the mean divided by the standard deviation. 10.5, 0.5 minus the mean divided by the standard deviation. And then that turns into 2.32 to 2.84. We've already looked up those numbers. But first, we need to say that we're going to approximate that with the Z distribution, which is equal to phi of 2.84 is the large one when it's positive, minus phi of 2.32 when it's negative. And so when we look these up, we're going to get 0.9977 and 0.9898, which gives us 0.0079, and this turns out to be a 21% error. So did I look at the wrong 1768? Okay, so up here for V equals 4, 1768, good. And for, 0079 was the first one. Okay, so we got 0.0079 twice here. Let me make sure I did my math right. 0102 minus 0.0023, 0.0079. Now, 0.9977 minus 0.9898 is 0.0079 as well. Okay, so it's just happenstance that occurred. Unusual. All right. So again, we just barely met the requirements for this, and we we didn't have very good results except for v equals 4. That was the only decent estimate that we have. The error is small there. So now let's look at changing this. We'll call it x now. We still have n is equal to 20, but now we're changing p is equal to 5. And I should have left this at 4, but I changed it. So 0 now instead of 4, we'll go 5 and then 10. And let's see how it changes for the 0 and the 10 especially. Okay? So first, mu is equal to NP, which is 20 times 0.5, which is 10. NQ is 20 times 0.5, which is 10. So both of those are met, and we've equalized them by putting P equal to 0.5. They're both the biggest they can be, right? They're both, together, they're both the same value, and so we have the most in both categories that we can have, okay? Equal values. All right, so it's balanced now. Let's see how this changing of P from 0.25 to 0.5 changes our approximations. So we'll start with x equals 0, and we're going to use the continuity correction, so 0.5. So negative 0.5 to positive 0.5. Now we do our transformation. I need sigma squared is going to be NPQ, which is 20 times 0.5 times 0.5. So 10 times 0.5, which is 5, right? So 5. All right, so I have negative 0.5 minus mu, which is 10, divided by the square root of 5. And then this becomes w, and then I have positive 0.5 minus 10 over square root of 5. And this becomes the probability that w is between, negative 4.7 and negative 4.25. Well, we have an issue. On our table, we don't go that low. We only go up to negative 3.49. And remember, I said if it was less than or equal to negative 3.5, then we're going to use 0.0001. So this is going to be phi. Let me write it out, though. I want you to write every step. Negative 4.25 minus phi of negative 4.70. They're both, we're going to use, since we don't have them in the table and they're very negative, we're going to use 0.001 for both of them equals 0. Now the actual, if you plug this into the binomial, right, so that's how I'm getting the actuals, by the way. So the probability that x is equal to 0 is n choose x, p to the x, q to the n minus x, n is 20, x is 0, so p is 0.5 to the 0. These are 1. And then I have q is 0.5 to the 20 minus 0, which is 20. This is 9.54 times 10 to the negative 7th. So the percent error is approximately 0%. That's a very good estimate. Now let's look at the probability of x equals 5. That's going to be continuity correction, 4.5 to 5.5. And then our transformation, so 4.5 minus 5, that's our mean, divided by this, it's not 5, it's 10. Our mean was 10. Our variance was 5, so we take the square root of 5. W, 5.5 minus 10 over square root of 5. This is going to give us, I didn't do my approximation here, I'm sorry. I left out something. So we'll do probability that z is between negative 4.70 and negative 4.25. So we'll do that. So now we're going to do wrong thing. We're going to do an approximation. Approximately, no, not yet. Sorry, we do have an equal sign. So this is going to be, for 10, this is going to be a 0.22 and a negative 0.22 and a positive 0.22. And now we have the approximation. Did I do the right one? No, I'm sorry, I'm looking at the wrong one. You're probably thinking, that doesn't equal that. All right. So 4.5 minus that, that's going to be negative 2.46. W is between negative 0.246 and negative 2.01. So now we'll say that's approximately Z between the same numbers, negative 2.46 and negative 2.01. This is phi of negative 2.01 minus phi of negative 2.46. We go to our table, part B, and I can clear this up pretty quick. And we need negative 2.01 first, negative 2.01, 0.0222, and negative 2.46, 0, 1, 2, 3, 4, 5, 6.0069. So, whoops. This is 0.0222 minus 0.0069 equals 0.0153. The actual, plugging into the binomial formula, probability x equals 5 is equal to 20, choose 5, 0.5 to the 5, and then 0.5 to the 15, or 0.5 to the 20, since P and Q are equal in this case. And this is going to equal 0.0148, thereabouts. And so this and this are pretty close, are they not? And so the percent error is only 3.4%. So that's pretty good. So we had 0% or thereabouts here, and now we had 3.4%. Now let's do probability x is equal to 10. That's going to be the probability that x is between 9.5 and 10.5. Okay. And then we do our transformation, 9.5 minus 10 over square root of 5, and 10.5 minus 10 over square root of 5. And this is going to be the probability that W is between negative 0.22 and positive 0.22. We're going to use the standard normal to approximate that. So we have the approximately. Z is between negative 0.22 and positive 0.22. And this is equal to phi of 0.22 minus phi of negative 0.22. So we go over to our normal distribution table. We're in the negatives, so we look at negative 0.22 is going to be here, 4129. Positive 0.22 will be up here, 5871. So 0.5, oops, I always forget to get my pen. 0.5871 minus 0.4129 equals 0.1742. The probability that x is equal to 10 is equal to 20 choose 10, whoops, 0.5 to the 10, 0.5 to the 10, which is about 0.1762. And so we have the approximation is 0.1742. The actual is 0.1762. It turns out that this is a 1.1% error. So having P closer to 0.5, that's all we changed between this and the last example. It made a big difference. Now our errors are manageable. 0%, 3.4%, and 1.1%. Okay? And then if you went to x equals 15, it should be close to 3.4% again. And at x equals 20, hopefully the error would be close to 0% again. Since this is a symmetric distribution, it should work that way. All right. So the conclusion here is that as p approaches 1/2, the approximation improves. As x approaches n over 2, the approximation improves. As n increases, this is the biggest thing, it will take care of either of these other two. The bigger n is, the better the approximation. And that's based on the CLT, central limit theorem. Okay? So I'm giving you the one-sided probabilities here, and we're going to use these in the following of this. We're going to continue with this example using these. So up to now, I've been giving you x is equal to k. Now I want less than or equal to k, less than k, greater than k, greater than or equal to k. And so we have to be very careful with our continuity correction. We've been doing the easy part so far. Now it becomes a little more tricky. So you have to be very careful. I've given you the 4 formulas. Please add them to your formula sheet. So if I want the probability that x is less than or equal to k, then if here is k and here is k plus 1/2, I have to use a continuity correction. I have to when I'm doing these approximations. So if I want, so I have either k plus 1/2 or k minus 1/2. I'm doing the less than or equal to, so this has to be included. Which one do I need? I need the plus 1/2 to include that. Otherwise, if I did the minus 1/2, I'd miss it. So the minus 1/2, this is going to be less than, this one's going to be less than or equal to. So the less than or equal to, I've got the plus 1/2. The less than, I've got the minus 1/2. Now, for a greater than, k, I'm either going to go k plus 1/2 or k minus 1/2. If I've got greater than, I do not want to include k, so greater than is here, k plus 1/2. But the greater than or equal to, I need to include this, so I need to go down below it, so this is going to be the greater than or equal to, the minus. So that's how you do it. And then the transformation is still you subtract mu and divide by sigma for all of these. Okay? So I don't memorize the formulas so much, but it does help if you have them written down. You can think through them. All right, now let's continue. So we need to find the probability that x is less than or equal to 10. So remember that x is a binomial 20 and 1/2 or 0.5. So mu was np, which was 20 times 1/2, which is 10, and sigma squared was npq, which is 10 times 1/2 times 1/2, which is 5. Okay. Now I need less than or equal to 10. So I'm going to just draw and say 10. I need less than or equal to, so I need to go from above 10. So that's going to be 10 plus 1/2 to get the less than or equal to. So I need the probability that z is less than. I can say equal to, but less than works too. Now I need 10 plus 0.5 minus the mean, which is 10, divided by the standard deviation, which is square root of 5. Okay? And then this is going to be the probability that z is less than 0.22. We've looked this up before. It's 0.5871. Now, we're going to get a different answer because we're approximating a discrete distribution. So now I need less than 10. I don't want to include 10. So I need to start with 10 minus 1/2 and go down. So this is going to be the probability that z is less than 10 minus 0.5 minus 10 over the square root of 5. And this should be, yes it is, the probability that z is less than negative 0.22. And we can look that up in our table too and find 0.4129. And that's the answer there. And you'll notice there's a big difference between these values. Now for greater than or equal to 10, I need to include 10, so now I need to go below 10 and in order to include this. So I need 10 minus a half. And so I have the probability that z is greater than k minus a half, so 10 minus a half, minus the mean over the square root of 5. And this is going to be the probability that z is greater than negative 0.22, which is 1 minus the probability z is less than negative 0.22, which is 1 minus phi of negative 0.22, which is 1 minus, we looked this up, it's 0.5871, or I'm sorry, minus 0.4219, which is equal to 0.5871. All right. Now, because remember, we need the, if we're doing the greater than, we need the or you can just look it up, and you'll get it directly. Okay, so if you, one of the tables allows you to look at greater than. Oh no, that's right, it's a positive. So you have to subtract this from 1, or use symmetry, and then you can figure it out. That the probability that z is greater than negative 0.22 is the probability that z is less than 0.22, okay, which is what we saw up here, 0.5871. So you can use symmetry to get this as well. Okay, so now I need greater than 10. I don't want to include 10, so I need to come up to 10 plus a half. So I have the probability that z is greater than 10 plus 1 half minus the mean, which is 10, over the standard deviation, square root of 5, equals the probability that z is greater than 0.22, which is, you can look up directly in your table B, which is 0.4129, which is the same as the probability that z is less than negative 0.22 by symmetry. Okay, so you'll see again that there's a big difference between the less than or equal to, or less than or equal to, greater than, and less than up here, and a difference between the greater than or equal to and just the greater than here, because we're estimating a discrete distribution. All right, that's it for this video. So please update your formula sheets, and if you have questions, please come to virtual office hours or email me. And again, give me plenty of time to respond to you. Please don't wait till the last minute, so I can help you before the deadline. So please take care of yourself, and we'll see you next time.